Howdy, it's Mr. Russell. We're going to talk about solubility curves. So a little bit of vocabulary. You need to know what a saturated solution, an unsaturated solution, and a supersaturated solution are. All right. A saturated solution, in short, is my definition is a solution that has too much of it of solute and has reached its limit. An unsaturated solution has not reached its limit. And a supersaturated solution has reached its limit and then been heated up and cooled down and gone through an entire process. So we'll get to that. So let's just review just a little bit. If pain medications can be taken as a powder or a tablet, but they have the same ingredients and the same mass, but why do powders work faster? Well, that's because powders have more surface area, right? And then when using cold water to dissolve sugar, it dissolves slow. Why? Because the cold water molecules have less kinetic energy, so there's less interaction, there's less solute to solvent contact. So let's talk about saturation. It is when what happens when you get to the point where if you start adding enough salt to or enough of a solute to a solvent, is there a point where the solvent can just not hold anymore? Yes. That point is the saturation point or the saturation content. For every solvent-solute combination, there is a limit to the amount of solute that can dissolve. All right. So now there are three types of solution: the unsaturated, the saturated, and the supersaturated. All right, so the unsaturated solution has less solute and exists under the curve. Let me see that. And what you'll see is these curves right here. Now, on this curve, you will see temperature plotted on the x-axis, and you'll see the solubility plotted on the y-axis. Now, it has kind of weird units. It's a solubility of the solute in grams per 100 milliliters of our solvent. Now, almost always this is going to be water, but it's that 100 milliliters of solvent. So that's the only unit we could have for that is grams of solute per milliliters of solvent. So that's the way we do that. So less solute than an unsaturated solution has less solute than a saturated solution. All right, and exists in the bottom part of the curve. So means I can add more solute and it will still dissolve. So a saturated solution means it has the maximum amount. If I add more solute to it, it will not dissolve and it will just exist as a solid. No, it will not go up to the supersaturated zone. It will stay at this point. It will reach the maximum number, and everything else that you will add to it will still be a solid. Okay, so we're thinking in terms of just adding solid solutes to liquid solvents at this point. All right. Now, a supersaturated solution is when it has been heated up. All right, so an interesting thing, we have an unsaturated solution here, and then it has been saturated, okay, and then it has been heated. So what has happened is that, let's say it was saturated here, and I ended up having a little bit extra right here. You see I have a little bit extra. So I heated it up, so I increased the solubility. Therefore, it dissolved all that little extra stuff. But then I cooled it down. Remember, I went from 50 degrees to 25 degrees. So if I cooled it down, it ended up being a supersaturated part. But if I disturb this in any way, if I add one even little crystal, one little molecule of my solute, everything will fall back out and fall back into the saturated zone. So these are actually very delicate. I can prepare these in front of you, but they don't keep. I end up if I let them sit out for a day, they end up looking like this. All right. Um, all right. I wish I could show that to you, but you'll have to watch the video I attached to that. So just to review, you'll see this curve a lot. Just know that this unsaturated zone is the one on bottom. The saturated is on the line. And then the supersaturated zone we'll just call for here. All right? We'll just say that this is, that's an oversimplified model. This is the model you should really be trying to think about, but this is the oversimplified model. If anything above the curve is supersaturated. So very often you'll see one plot right here, and you will see 3 different solutes, or you'll see many different solutes on there. Okay, so the solubility is 100 grams, and the temperature is 60 right here. So if I asked you to about the solubility of if I said that the solubility was 100 grams and the temperature was 60 degrees Celsius, then that's what you would look at, okay? And so you would look at this point right here. And so if I asked you that it was about potassium nitrate, well, what would you say? Well, you would say that was unsaturated. But if I asked you if it was sodium chloride, what would you say? You would say that was supersaturated, okay? So let's just review the solubility of gases because it's always helpful. The solubility of a gas increases with added pressure. So if I increase the pressure, I will actually increase the solubility. Just remember, gases will like a lot of pressure. That's why we like to keep our sodas under pressure. Okay, and then gases also like it cold. All right. If a cold soda will hold its CO2 and will hold its fizz a lot better than a hot soda. All right, so if we increase the temperature, we will actually decrease the solubility. Now what that means on these curves is that the curves will actually slope downwards. So it's easy to see which one is a gas because it's sloping downwards, it has a negative slope. Now a solid, if we increase the pressure right here, pop quiz, what happens to the solubility? Nothing, all right? It has no effect on the solubility for increase of pressure. But if we increase the temperature, we will increase the solubility right here. So if we look at these curves right here, the ones that are sloping up are going to be solids, okay? Because we're increasing the temperature, we're increasing the solubility. Now if look at this guy right here. This guy is sloping downwards. Oh, well, he must be a gas. All right. Just remember, the gases like it cold and solids like it warm. So, just this breaks it down to the bare bones. Solids have a high solubility, and if they're hot, so solids will slope up, and gases will slope down. And then solids will have no effect if pressure is plotted on the x-axis, but they will have an increased solubility if pressure is on the x-axis. Okay, now most of these that you'll get are going to have temperature on the x-axis, so really just worry about temperature. If you see a whole bunch of conflicting lines, it's important to pay attention to the arrows. So a solubility curve is a graph that shows how likely a solute is to dissolve in a solvent at a given temperature. So the x-axis right here, like I explained before, is the solute dissolved per 100 grams of water, okay? Almost always is going to be water, and it's almost always going to be 100 grams. Really, you just need to know about how much solute. That's the mass of solute, so 10 grams, 20 grams, 30 grams, 40 grams. On the x-axis, This is the temperature, just in degrees Celsius. So, at what temperature will the solubility of potassium chloride be 49 grams per 100 grams of water? So, we find potassium chloride right here, and we identify its curve, and we ignore all the other lines. And then we look at 49 grams. So, well, that's about 50, right? So, I'm going to kind of draw my imaginary line around 49 grams. And then I'm going to try to find that temperature at which it intersects KCl. So that would be this line right here. So what temperature would that be? Oh, well, that would probably be about 78 degrees Celsius. Now, between sodium nitrate and potassium nitrate, which has a higher solubility at 50 degrees Celsius? So, isolate your two, sodium nitrate and potassium nitrate, and which has a higher solubility at 50 degrees Celsius? Well, you can see your line right here. Which one has a higher one? That's going to be sodium nitrate. What is the solvent shown in the graph? Remember that thing I showed you? Look over here. 100 grams of grams of solute per 100 grams of solvent, which is water. So that would be water. List any 3 solutes shown on the graph. Well, you could list any of those, so that doesn't matter. At what temperature potassium nitrate and sodium nitrate have the same solubility? What is that solubility? So, potassium nitrate and sodium nitrate. Let's see if we can find those. There's sodium nitrate and there's potassium nitrate. Where do they have the same solubility? Oh, that is right there. All right. So that, let's see, what temperature do they have? So let's look at the x-axis. That's going to be between 70 and 80, closer to 70. So that's going to be 72 degrees. And this one is going to be between 130 and 140, probably closer to 140, maybe. So 137 grams per 100 grams of water. That's how you must write that, okay? 137 grams per 100 grams of water. Which solute is most likely a gas? Well, obviously it's the one that slopes downwards, right? Okay, so as the temperature increases, the solubility would decrease for a gas. 130 grams of potassium nitrate is added to 100 grams of water. The solution is heated to 75 degrees Celsius and all the KNO3 dissolves. What type of solution is it? So here's KNO3. 130 grams is added to 100 grams of water. It's heated to 75 degrees Celsius, so it is at this cross-section point right here. What type of solution is it? Well, what zone is that going to be? Well, it's below the line, so it's going to be unsaturated. Easy enough. The solution is cooled to 70 degrees, and all the KNO3 stays dissolved. What type of solution is it going to be? It's right on the line, so it's going to be saturated. The solution is carefully cooled to 65 degrees, and all the KNO3 stays dissolved. What type of solution is it going to be? So now it's here, it's actually above the line. So it's going to be supersaturated. Now, word of note, supersaturated solutions don't last too long because they will, any kind of disturbance, if you shake it too much, if you add a little bit, any kind of impurity to it, all that stuff falls out and it falls back down from here to here. So, if a crystal of KNO3 is added, and all the excess KNO3 settles out as a precipitate on the bottom of the beaker, what type of solution is it going to be? Now, it's going to be saturated, because here what happened was it fell from this point in part C, it fell to this point right here. It did not fall below the line, it fell to the line, okay? So it fell right on right here. Now, another question could be how much solute fell out? Well, you'd have to look at this. This is about 130 grams. And then this one is about 111 grams. I'm sorry, 115 grams. So 130 minus 115 is going to be 15 grams of solute fell out. Okay, the difference between here and here. All right, so that's another question you might see. All right, I want y'all to have a great day.